All right, welcome back to Physical Science. I'm Mr. Harriman, going to teach you guys how to convert grams to moles or moles to grams. So our molar mass conversions, okay? Now, the question I have for you is how many grams are in 3.7 moles of BeF2? Now again, we're looking for grams. We're looking for the mass, all right? So if you get out a scale, throw something on it, it tells you the mass. That's what we're looking for. However, what's a mole? Just remember, a mole is an amount. Like a couple is 2, a dozen is 12. A mole is 6.02 times 10 to the 23rd. We use, and that's a monstrous number. Okay, zillions and zillions and zillions, a way bigger number than anything I can think of. And the reason we use such a large number is because we're dealing with atoms and compounds or molecules. So we need a big number because there's so many molecules in just a small substance. All right. So anyways, we're looking for how many grams are in 3.7 moles of BeF2 beryllium fluoride. All right, now the first thing you need to do is kind of a pre-step, is to find the molar mass conversion, okay, for BeF2. Now to do that, you're going to need your periodic table. You go to your periodic table, you find your elements beryllium and fluorine, and find the average atomic mass, the molar mass. It's that goofy number on each atom. So for BeF2, there is 1 beryllium, because if you don't see a subscript, it's 1, and 2 fluorines. So over to the side here, I'm just going to kind of do a little thing. So we have beryllium, which is 9.0. So beryllium, all right, is 9.01 grams per 1 mole. That means if we had that 6.02 times 10 to the 23rd atoms of beryllium, and we put it on a scale, it's going to measure 9.01 grams. That's what that means. All right? And then we have fluorine, which we have 2 of them. And again, when you're doing this on your own, you don't have to do all of this. But fluorine is 19.00 grams per 1 mole. And there's 2 of them. So we have beryllium measuring 9 grams for every mole, fluorine 19, and this fluorine 19. Because again, Be, there's 1, F2. Now what does that add up to? So if we add it all up, 19 plus 19 is 38. 38 plus 9 would be 47.01. Make sure I do my math right. Yep. All right. And that's grams per 1 mole. I'll kind of erase that little equal sign because that might confuse people. And that's BeF2. Now that is not the answer, but that is just to get our conversion. And again, what I mean by conversion, if I'm looking for moles, or if I'm looking for grams, the mass, this conversion will help me. All right, so we start, grab a different color marker here. We start now our story problem, now knowing our conversion, changing moles to grams or grams to moles. Kind of like if I said 3 feet in 1 yard, that's a conversion. So I can find feet if I know yards, or I could find yards if I knew the feet with that 1 to 3 conversion. That's what this is. It's a conversion. 1 mole of a substance will equal 47.01 grams of BeF2. All right, so we always start with what I gave you. That doesn't work. 3.7 moles. Now, to do it more accurately, you need to put the compound, this matters down the road, not so much for freshman science, but if you take chemistry your junior year, you will definitely need to put this because it gets into a big process called stoichiometry, which again, we're not getting into right now. So we have 3 moles of BeF2, and we're going to make a table, all right? Now, the trick is to get rid of moles and get grams. So again, we're taking moles and turning it into grams. We need this conversion. So we're going to say a mole of BeF2 goes down here with a mole of BeF2. Why would I do that? Well, the conversion over here is grams per mole. So grams of BeF2 and moles of BeF2. Now, if I was looking for moles, I would take this conversion and flip it. So it can be flipped. It can be rearranged. It can be 47.01 over 1, or it could be 1 mole over 47.01 grams. You see how I inverted it? I flipped it? That is perfectly fine. You can do that if you need to for our table. But in this case, we don't, all right? Because I'm looking for grams, so I can just keep it the original. I don't need to invert it. So when you're doing the problems, and all of a sudden you start with grams, that means grams needs to be down here, and you'll need this version of it, the flipped version. So this would go here if we had grams, and we're looking for moles. All right, so now, what is our conversion? Well, guys, the trick is this, and I teach my freshmen, the ugly number always goes with the mass, the grams. So 1 mole is equivalent to 47.01 grams. All right? The moles of BEF2 cancel with the moles of BEF2. So the only unit I'm left with now is grams, which that's what we're looking for. Now mathematically, how do I find the answer and what's this equal? I think I might have run out of my video space, so I'll have to do it down here. So what's it equal? You mathematically do times across the top and divide the bottom. So I take my calculator, I do 3.7 times 47.01 and then divide by 1. But truthfully, you don't need to put divide by 1 because it's the same thing. And the answer is 173.94 grams of BEF2. And that would be your answer. So again, let's go back to, let's talk about what we had to do. We're taking moles and turning it into grams. So we're taking moles and turning it into grams. To do so, you need a conversion. To find the conversion, find the molar mass of our substance. To find the molar mass of our substance, we use our handy dandy periodic tables. We had 1 beryllium, 2 fluorines, added all 3 up to get our total molar mass conversion. And then use that. Just a quick reminder again, this can be flipped if needed. So when might it be flipped? If I said how many moles are in 40 grams of that, we'll say, in fact, let's just show that. All right, so let's just erase this. How many moles are in, we'll change it up a little. How many moles are in, I don't know, 100 grams of BEF2? I could ask that. So we're trying to find the amount here, the number. So I'd set it up. We start with 100 grams of BEF2. Now again, for my class, do I need to write the BEF2? No, but for future, it is needed, trust me. So we make our table. Well, if grams are up here, grams got to be down here. And then moles up top. Why again do we write moles up top? Because we're looking for moles. The grams cancels out with the grams, and I'm just left with moles as my unit. Moles of BEF2. So we go back to our handy dandy conversion we found out earlier. We do the same process. We always put the ugly number with grams. So this time, it goes on the bottom. Grams and 1 mole. 1 always goes with mole. So how do we do this mathematically? Well, we again multiply the top, then divide the bottom. 100 times 1 is still 100. Then divide that by 47.01, and that equals 2.13 rounded moles of BEF2. And that's how you would solve if we're looking for moles. So again, this molar mass conversion can be inverted to find what we're looking for. All right? If you have any questions, shoot me an email or talk to me in class.